Am I audible now?
Yes, sir.
Okay, good. So that's what, and we have seen the most important type of reaction which aldehyde ketones can give is the nucleophilic addition reaction. Okay, aldehyde and ketone can undergo addition of nucleophile, and it depends how well a nucleophile, how quickly, what will be the rate. Okay, that depends upon the structure of aldehyde and ketone. Got it? We were looking at addition of HCN. Okay, addition of HCN lead to the formation of a compound known as cyanohydrin, and as the name indicates, cyano and hydrin mean there is CN and OH. Okay, how come CN and OH come into picture? Look at this. Got it? There is CN and OH. Okay, is it clear? So we can compare the rates of cyanohydrin formation. Okay, I will give you some aldehydes and ketones, and you can compare where the cyanohydrin is going to form most easily and where it is going to form with maximum difficulty. The first one is a methanol, second one is 2-butanol, and the next one is 3-pentanol. Marwa, I hope you can see the question.
Yes, sir.
Okay, good. So can you tell me where the rate of cyanohydrin formation is going to be maximum?
Yes, sir.
Yeah, it is going to be maximum in methanol. Got it? Because it is the smallest aldehyde. Okay, and it is going to form the cyanohydrin most easily. Okay, between aldehyde are most reactive. Okay, the other two are ketones. If the ketones have two alkyl groups on both the sides, you need to check where the alkyl groups are larger. With larger alkyl group, the difficulty of addition is going to be more. Am I clear? So Pentane 3-one, if you look, you have the larger groups, okay? On both the sides. Yeah, Jasleen, am I audible? So wherever you have a larger groups, okay, the addition is going to be difficult, okay? It is going to be slow because the groups are going to prevent the attachment of nitride, okay? So the rate of cyanohydrin is going to be like this. Is it clear or not? Jasleen, is it clear that the cyanohydrin Marwa? I hope it is clear.
Yes, sir.
Okay, great. Next is you will be asked about the rates of the cyanohydrin formation. You will be asked about the conversions involving in cyanohydrin formation. Okay. So in NCRT theory, they have just mentioned that cyanohydrins are useful synthetic intermediates. Okay. What it means? It means, but they have not given any question. In the theory part, they have not given. But if you look into the back exercise, you will see the applications of the cyanohydrins, okay, in the preparation methods. We have KCN and H plus. Okay, this lead to the formation of a cyanohydrin, right? So OH and CN are going to come up, right? That's why the name cyanohydrin that we discussed. Okay. Now what are the other conversions which you can do? Other compounds which you can prepare using cyanohydrin. Getting my point or not? So if I treat this with H2 and Ni, what am I going to get? Marwa, Jesslyn, can you hear me?
Yes, sir.
Yeah, so what am I going to get? If I use H2 and Ni, H2 and Ni will do the catalytic hydrogenation reaction. Got it? So where the catalytic hydrogen, which part will get hydrogenated? The one which is carrying the double bonds or the triple bonds. So the C multiple bond will get hydrogenated to CH2 and H2. Getting my point or not? If I do the complete hydrolysis with excess of water, okay, excess of water, complete hydrolysis, the CN triple bond N will be hydrolyzed, okay, and you will get 3 OH groups. Got it? Those 3 OH group will convert it to carboxylic acid. Getting my point or not? Marwa and Jaslin, can you name this acid? Hmm. Yeah, Marwa. Jaslin. This is 2-hydroxypropanoic acid. Got it? 2-hydroxypropanoic acid is there. You can convert it to various other functional groups, okay? And so these conversions are this conversion is given in NCERT, okay? This one. So just keep in mind, very important, very basic also. Next is we are going to move towards the addition of NHSO3. Nucleophilic addition of NHSO3. So just like when you add KCN and H plus, you have OH and CN. When you add NHSO3, you will have not OH and CN. You will have OH and SO3Na connected to a carbon. There you had OH and CN connected to a carbon. That's why it was cyanohydrin. Okay. This product is a white crystalline solid. So in a way, its characteristic is important for us, because if the reaction happens and if the product is formed, if the reaction takes place, we can make out by the reaction mass, it turns into white crystalline solid. And this name is sodium bisulfite adduct. There the name was cyanohydrin. Is that clear? Sodium bisulfite adduct is a white crystalline solid. I hope it's clear to everyone.
Yes, sir.
Okay. And how this reaction takes place? This reaction is actually addition of SO3Na. Okay. This is sodium hydrogen sulfide. Okay, bisulfite. Or sodium hydrogen sulfide. This is a weak nucleophile because it is a bigger group. So its addition is bit difficult. Okay. Aldehydes can react easily. Okay. And ketones are less reactive. Aldehydes, they give this reaction. Got it? For example, if we take two pentanol and three pentanol, can you see this, all of you? So tell me quickly, who is going to react with NHSO3? Are both going to react or any one of them going to react? I hope everybody is getting my point. Yeah, Jovita, am I audible? Not Jovita. Jaslyn, am I audible? Jovita was there in the NEET class. Yeah. Yeah, Jaslyn, Marwa, got it? So tell me, which will react and which will not react, right? Look at aldehydes can react easily. Okay, look here closely because aldehydes are more reactive than ketones. In ketones, only aliphatic methyl ketones. Okay, what does mean methyl ketones? This is a very important point. You need to have a ketone where one of the group is methyl, got it? CH3. Is it clear or not? Like this one. So this can react, this will not react. Why CH3 is so special about it? Jaslyn, why? Marwa, why CH3? Any idea? Because that will make this group smaller. Got it? So they can react. Next is, so you can also separate them. Okay. So when you and treat them with NaHSO3, this is going to react and this is going to form a white crystalline solid. Marwa, is it clear?
Yes, sir.
Yeah, and then you can Then you can filter it and boil it with HCl. Okay. And you can separate them. Got it? That's how we do the separation. So this method is important. Next is addition of Grignard. Addition of Grignard or formation of alcohols. So this is actually the preparation of alcohols which we have already seen. So just I am taking it so that you can quickly recap. So for the sake of practice, I have taken different aldehyde and ketones. Got it? So what is X and Y? And what is P and Q? Tell me quickly. Yeah, Jesslyn, Marwa, I hope both of you can hear me. Just tell me what is X and Y. And what are P and Q? Very important to revise this and the previous chapter also. X is, this is CH3 minus, right? It is going to add, O minus is going to form. So X is the structure with CH3 added to it and double bond O being converted to O minus in MgBr. Got it? And water will change this OMgBr to OH. So I told you that ketones upon addition of Grignard will give you tertiary alcohol. Got it? I hope you remember it. If not, no problem. Just this is the question which can make you understand. P is, this is Mg is positive. benzene is negative. This benzene is going to get added to C double bond O. Double bond O is going to become single bond O minus. And then hydrolysis will give you OH. Got it? I hope this is clear to all of you. Any doubts? So CH2OH and will give you primary alcohol, any other aldehyde will give you secondary alcohol. Okay. Ketones will give you tertiary alcohol. This you must remember, very, very important. Not only for the chapter of aldehyde and ketone, but for alcohols, ethanol also. Got it? So this I hope is clear to all of you. Okay.
So can
Yeah.
you explain how P is formed?
How P is formed? Yeah, sure. So you have taken pH MgBr. Got it? Phenyl magnesium bromide. Phenyl is negative. Magnesium is positive. Magnesium is +2. Got it? And you have taken the smallest aldehyde, which is the formaldehyde or methanol. Right? So this is delta this carbon is delta positive. Oxygen is partial negative charge because oxygen is more negative and carbon is less electronegative. So carbon will carry. You can think of it in this way. CH2, O minus and C plus. But in the case of magnesium bromide, okay, magnesium carries the positive charge and the carbon phenyl carries the negative charge. Got it? Clear?
Yes.
So pH will get added to the carbon atom carrying the positive charge. So pH CH2 O minus and MgBr and that will get converted to OH. Got it? So you will get a primary alcohol upon acidification. You are going to get a primary alcohol. With ketones, you are going to get a secondary alcohol. You need to remember, you need to look for the groups, okay, which are there in the ketone. Okay, accordingly, you can take the ketone and the grignard. Appropriate ketone and a grignard you can take. Getting a point or not?
Yes, sir.
Next is addition of alcohols on aldehyde and ketones. If alcohols are added to aldehydes, you end up with hemiacetal. And acetals. Hemiketals and ketals. Ketones, if the alcohols get added, ketone one with 1 mole, you are going to get hemiacetal or a hemiketal. Ketone will give hemiketal, as aldehyde will give hemiacetal. With 2 moles of alcohol, getting my point? So let's discuss the actual structure. This you understood, basic idea. Okay. What are hemiacetals and acetals? Okay. Aldehydes result into hemiacetal or acetals. Ketone result into hemiketals or ketals. Got it? Is it clear or not?
Yes.
Okay, so let's see what are their structures. This is an aldehyde. Okay. What will happen if you add methanol? 1 mole. You need to take H plus as a catalyst. H plus or dry HCl. Don't take water, otherwise they will break again. Getting my point or not? So what are we going to do? This is minus and C is plus. Okay. Reacting aldehyde ketones with some reagent is about knowing the positive and negative charges. Okay. During the reaction, you need to connect the positive charge to the negative charge or negative charge to the positive charge. Okay. Like that you need to do. Okay. So this is always minus and C is plus because oxygen is more electronegative, that's we have seen. In alcohol, okay, H plus and O minus. Got it? Because oxygen is more electronegative than hydrogen. Is it clear or not? Yeah. So this is basically O, H, H and H. And OCS. Clear? Any doubts on this? Marwa, is this clear or not? Jaslin? If you react with one more mole of CH3OH, that means overall totally we have reacted with 2 moles now. Till now, 1 mole is already reacted. 1 mole more. Got it? What we need to do? I will remove water from that OH and this methanol and put 1 more methanol on the carbon. Is this clear or not?
Yes, sir.
So you will have this is acetal or a ketal. This is because this was an aldehyde. You started and 1 OH and 1 OCH3. If you have 1 OH of on aldehyde and 1 ether, this is called hemiacetal. And if you do not have OH, if you have reacted with 2 moles of alcohol, now you will not put the word hemi, you are going to put the complete name acetal. Is it clear? Let's see how can we get the ketal. Okay. Ketal means the name indicate that it has been formed from a ketone. Got it? That's what ketal means. Okay. Means it has been formed from a ketone. That's why ketal. Okay. So let's take a ketone. And let's take any alcohol. Which alcohol should I take? You can tell me. Yeah, Jasleen, Marwa, tell me which alcohol can I take? Hmm? Yeah, I've not heard properly. Yeah, just let me know. Marwa and Jasleen, both of you, which alcohol can I take? Yeah, we can take any ethanol, right? OH, H, and C2H5OH, right? So if I react with 1 mole of ethanol, okay, this double bond will change to OH and ethanol will bring in this OC2H5 on the carbon atom of the ketone. This was a ketone. Okay, so you will have this. Got it? Clear or not? So this is what is the name of which class of compound is it? This belong to what class of compound? It's hemi because there is one OH and it is prepared from ketone. Hemi-ketal. Got it? And if you react with 2 moles, you need to take dry HCl. Which act as a catalyst. What are we going to get? Marwa and Jasleen, tell me quickly. We are going to get OC2H5. Getting my point or not? Okay, so this is ketone.
Yes.
From ketone, you can either get a hemiketal or a ketal. If you have just if you put 1 mole of alcohol, one OH will still be there, that is hemiketal. And if you react with 2 moles of alcohol, that will be ketal. Got it? Actually, the ketones, for ketone, the reaction is a bit difficult. So instead of taking 2 moles of alcohols, what we try to do is we try to take a diol. What is the name of this diol? Can you tell me? This is ethylene glycol. Okay. An ethylene glycol, water will be removed. So you have two OH groups. So it served the purpose of two alcohol molecules. Got it? Is this clear or not? So this is going to be a cyclic ketal. It's not hemi, okay? Because we have taken, we have taken one alcohol, but it had two groups, okay? Is it clear? So it is a cyclic ketal. I hope this is clear to all of you. Any doubts on this? Jaslin, Marwa, I hope this is clear. Any doubts?
Yes, sir.
Okay, now let me give you some questions. So what is the correct structure of the product? Or I will draw it here. Yeah, tell me quickly. Yeah, can you see the question? Marwa, can you see the question? Jaslin, can you see the question?
Yes, sir.
So tell me what is you are going to do. Very important question. You need to draw the structure. Okay. Ketone. So first of all, we can start in parts. Okay. So we have taken a ketone, right? This is the ketone. Got it? So the first question which comes to our mind whether we are going to get uh, an acetal or a ketal, and the answer is quite clear that we are going to get an acetal. Okay, why we are going to get an acetal? It's because sorry, we are going to get a ketal. I made a mistake because it is a ketone. Okay, so we are not going to get an acetal, right? We are going to get a ketal. But which ketal are we going to get? So you need to look for the structure of the alcohols and the ketone which is given. Getting your point? So ketal, or are we going to get a hemiketal or a ketal? But we have taken only one alcohol. Okay. If we have taken just one alcohol, normally with the one alcohol we get a hemi. Okay, one alcohol gives you OH and OR, so that gives hemi. But even if we have taken one molecule of alcohol, but we are not going to get hemi, we are going to get a complete ketal, because the reason being that one molecule solves the purpose of two alcohols. Okay, because it is a diol, right? So we are going to get a ketal. So tell me which ketal we are going to form. Have. Hmm.
Sir, is it option B?
Yes, absolutely correct. Option B. Yeah, because you can put them side by side, okay, and remove water like this. Remove the water, H2, and you will get your answer. And this double bond O will not remain a double bond O. You are going to make it like this. Okay, will be connected. The carbon of the ketone will be connected to two oxygen groups. Got it? I hope this is clear, right? Hmm. Let's move to another reaction, and that reaction is very, very important, and it is not a single reaction, but it is a group of reactions. Okay, but the thinking is same. It is the reaction of reaction between NH2Z. Okay, the Z can be different groups. Okay, but as I told you, this is not a single reaction. It is a group of reaction. And the Z can be different for different reactant, but the overall thinking is going to be same. Okay, it is the pattern of reaction in this whole group is going to be same. So reaction of aldehyde and ketone with NH2Z, and I'm collectively calling this NH2Z as ammonia derivative. Okay, reaction with ammonia derivatives. Is it clear or not? So what reaction are we going to have? The reaction, writing the product of the reaction is very easy. Okay, it's very easy to write the product. You need to take slightly acidic medium, okay, to catalyze this reaction, and the product can be written very easily by removing this H2 and O. You can remove the water. Is it clear? Okay, this is the product. I can write minus H2O. Okay, reaction with ammonia derivatives. Collectively, I have called this as ammonia derivative. These compounds. So what these ammonia derivatives specifically are, that depends upon the Z. If the Z is an alkyl group, R is the any alkyl group or pH. Okay, the product which is going to form R or pH, whichever you have taken. Okay, these are known as imines. NH2 is amine, this is imine. Is it clear or not? This is imine. Got it? These are also known as Schiff's base. Okay, is it clear? Next is the other reaction in this class of reaction is where the Z is OH. So Marwa, can you tell me what is the name of this reactant? What is the name of this reactant? Yeah, it is known as yeah, you have to speak loudly, I can't hear. It is known as hydroxylamine, right? Because amine and OH hydroxyl group, okay, hydroxylamine. So Jesslyn, what are we going to get? as the product. Hmm. Yeah, Jaslin, am I audible?
The OH will attach to
Hmm.
C.
Yeah, remove the water. Okay. Remove the H2 and O. Okay. And club these two molecules together. Okay. So hydroxyl amine it was the reactant. And the product, what is the name of the product? Product is known as some part of the name of the reactant. Hydroxyl. So I took OX from the hydroxyl. Okay. And IME from the amine. Oxime. Marwa, is it clear how it is named? The product is known as oxime. You need to remember the reactant as well as the name of the product. Very, very important for all of us. Clear or not? If I took NH2, NH2, what the reactant is known as, and what is the name of the corresponding product? Getting my point or not? The name of the reactant and the name of the corresponding product. So this is very, very important, hydrazine. And the product is known as C double bond. Now the O is removed. Okay, similarly, here also you are going to follow. In all of them, you are going to follow the same method. Okay, you are going to remove the H2 from N and O from oxygen. And the nitrogen will get connected. Okay, so that reactant which I took was hydrazine, and this is hydrazone. Jesslyn Marwa, can you tell me the name of the next reactant which I am writing? Very similar to the above reactant, just a minute change, slight change I have added to it. Yeah, tell me. What is the name of the reactant? Marwa and Jesslyn, tell me quickly. What is the name of the reactant and what is the name of the product?
Reactant.
Hmm.
Phenyl.
Phenyl.
Yeah, phenyletrazine. Right. Because I have put a phenyl group. Got it? And what is the name of the product? The product can be formed in a similar way in which we have generated the above products. Very simple method. Okay, remove the water, Got it? Is it clear or not?
Yes, sir.
Okay, this is so hydrazine. That was hydrazine and hydrazone. And this is phenylhydrazine and phenylhydrazone. Got it? Very, very important to remember the name of the reactant as well as the product. Very important. Got it? Now I'm going to write the another reactant of this series of reaction. Very similar to the above reactant. Okay, just I've added few more things. Okay. So you can name the reactant as well as the corresponding product form. And this is the star of this whole series of reaction, which is the most common among all these above reaction. This is the most common. Got it? So what is the name of the reactant and what is the name of the corresponding product? Tell me quickly. Hmm. Hydrazine, you have seen something added to hydrazine. Got it? And some more thing added to that compound. So tell me quickly. Hmm. Aisha, Marwa, Jasleen, tell me what it is. The reactant, name of the reactant, and the name of the product. This is hydrazine, phenylhydrazine with two nitro groups at the second and the fourth position. Got it? So it is 2,4-dinitrophenyl hydrazine and the product. And there is a name also, shortcut name to it. Yeah. Yeah, Jasleen, what's the common name? Instead of telling this whole complete name, it is known as Brady's reagent. Got it? Okay, do remember it. Very, very important to remember it. Okay. It's the Brady's reagent. And the product is that has the same name but just the last part instead of writing 2,4-dinitrophenyl hydrazine, We are going to make it as 2,4-dinitrophenyl hydrazone. Got it? Okay, and this is the star of this whole series of reaction. What's so special about it? Marwa, can you tell me?
Yes, sir.
The short form is 2,4-DNP. Okay, 2,4-DNP. 2,4-dinitrophenyl hydrazone. Got it? Is it clear or not? And these, why this is the star of this whole series of reaction? Because these compounds are bright. Yeah, and where they find their application, where do we apply them? Where do we apply these compounds? These are because they are colored compounds, so we can clearly make out that the reaction has taken place. And these 2,4-DNP test is used to detect aldehydes and ketones. Is this clear? Aisha, Marwa, Jesslyn, tell me quickly.
Yes, sir.
Aisha is not there today, so Marwa will tell reply. Okay,
Yes.
clear. So this is a very famous test. Okay, but the problem is, so because immediately you are going to make out whether the reaction has taken or not. Okay, but the problem is that you cannot make out whether it is an aldehyde or a ketone. All aldehyde and ketone give this test. Okay. Okay. But whether it is an aldehyde or a ketone, you can't make out. Right? That's the problem. But at least whether it is an alcohol, if it is an alcohol, it is not going to give the test. Okay. So whether it is an alcohol or aldehyde ketone, you can clearly differentiate. Got it? Next is the last reaction of this series. NH2, NH, CO, NH2. Okay. This is known as semi carbazide. Got it? and the product is again this made in the same way in which we have formed the above product. The product is formed by removal of water. It is known as semi-carb ozone. Carb azide and carb ozone. Got it? That is the only difference. Okay. Rest everything is same. Got it? Carbazide and carbazone. Okay. All these not only that 2,4-DNP, all of them are used to detect aldehyde and ketones. Okay. But out of all these, the 2,4-DNP is the most famous of all. Okay, so let's do some reactions. Very simple. The formation of product is very, very easy. That we know. Okay. But be very careful while forming the product. Right? Because sometimes you may be knowing the answer, but out of negligence you may have chosen, because in the options they can make still the problem difficult by giving the options which are very close to each other, which look very similar to each other. So you have to be careful and you need to choose the right option. Okay, so let me ask you the question. When A reacted with 2,4-DNP, you ended up with this compound. So what is A? Yeah, tell me what is A? Which structure represent the correct structure of A? Understood the point? Yeah, Marwa and Jasleen, tell me quickly. Look at the answer and just figure out which ketone may have given that.
PHCOCH3.
PHCOCH3, yes, absolutely correct. So you need to break this, okay? And that was NH2 and this was C double bond, okay? So PHCOCH3, this is acetophenol, okay? That gave this product. Got it? Very, very famous question and a very famous mistake. Okay. This is semi-carbazide. The question is very easy, just same as that of the above questions. Okay. And you need to tell me the product. The structure of the product. Hmm.
Sir, is it option
Option A. Yes, this is given in NCRT. Okay, and deliberately you have fell in the trap which I laid for you. Okay, this is wrong option, not the answer. Everything seemed to be correct. Okay. The same question is given in NCERT also. And the first option which will be written will be like this only. Okay. And you will feel that, okay, this is the correct option. Okay. So where the mistake? Where is the mistake? Part of it you are correct. Okay. You have removed the H2 and O and connected the double bond nitrogen. That is correct. But you have to be very careful while looking at the amine which NH2 which you are choosing. Getting my point or not? Got it? The NH2 which you are choosing, you have to be very careful about it. NH2 should not be the one which is connected to CO. Okay, because it is in resonance. It is this nitrogen which is going to react, not the one which is written adjacent to CO. Got it? Deliberately, I have planned that. Deliberately, I have shown that nitrogen so that you can remove the water and form the wrong product. But be careful. This is not the nitrogen which is reacting. It is a nitrogen which is away from carbonyl, which is the most reactive one. Got it? Clear or not? Any doubts in this? So this is Marwa, Jesslyn, tell me. This is not the answer. This is the wrong answer. But it is equally important to know what is wrong and what is a mistake, because this is the most obvious, seems to be the most obvious choice. But the right answer is this one. This nitrogen is going to react. Okay. Got it? So let's cover it up on the next time. So let me end the class, and I hope you noted down all the mistakes points where you can make the mistake which we discussed. Okay, let's cover it, continue it in the next class. Okay, bye bye everyone.